Good day everyone, good day and welcome to this presentation. This one is additional mathematics 2024 question 6, which is on 6A on AP and the B, which is on GP. Okay, so now the question reads, in an arithmetic progression, the sum of the first 12 terms is 2h2 and the sum of the first 14 terms is 357. Find the seventh term. So here we have been given this is an AP. So now having this information, we'll say Sn is equal to, this is the sum of an AP, where we say n over 2, then open bracket 2a plus open bracket n minus 1, we close, then d, like this. So now here what we have been given, sum of the first 12 terms. So sum of the first 12 terms, we are saying that here is then 12 like this is equal, where n represents 12, is equal to 282. Okay, so this is what we have this side, and also this side we have sum of the first 14 terms. Okay, 14 terms, we have 3, 5, 7. Here the question is to find the seventh term, and we know when you talk of the formula for the seventh term. So here the formula for this term, it's like this one, T n is equal to a plus, okay, open bracket n minus 1, we close, then d. So here what we don't have is, we don't have the common difference, we don't have the first term, we only have the terms. Okay, we have the seventh term, so we only have number of n. Okay, so first thing we are going to answer to find the sum of this given term, so that we express that them and we answer A and what D. So like for this one, where we have 12 terms, so which means that where there is this n here, this s will replace by what this value here. Okay, where there is this Sn here, will replace by what this one. So we'll do the substitution. We are saying that here we'll say it's 2, 8, 2, okay, 282 is equal to, where there is n replaced by 12, so here you say 12 over 2, okay, then open bracket, so here we have 2a plus open bracket, where there is n, it's 12 minus 1, we close, then do like this, we also close this side. Okay, so we have this. So having this side, we do the same, where there is s here, this side will replace by what this, what you have been given. So here we'll say it's 3, 5, 7 is equal to, where there is n replaced by 14, so here it will be 14 over 7, then open bracket 2a plus open bracket 14 minus 1, we close d, then we close curly bracket. So this is what we have. Okay, so having something like this here, we can reduce, or we can find the multiplicative inverse of 12 over 2 to the both sides. So here we are saying that it's 2 over 12. So even this side you say times, it's 2 over 12. So this is what we have. So having something like this, which means this one and this one will reduce, then this one and this one will reduce. Okay, so what are we going to remain with here? Okay, so here we have something like this and this. Here we are going to have 2a plus 12, take away 1, it's 13, sorry, 11d. Okay, 11d this side. Okay, so this is what we have 11d. Now here we are going to divide. How many times can this one go into this? So here we have 12, and there we have 2. So just checking this, as you can see here, we have 12 into this one. Okay, so let's divide. We have this one, 4, 2 there, it's 1, 2 there, it's 6, 6 here, or you can just use a calculator. This is additional mathematics. 6 there, it's 1. Okay, 6 there, it's 4. The remainder 4. Okay, 6 there, it's 7. Okay, so here we have is 47. Okay, then having this side 47, so this is equation 1. Okay, equation 1, we have this one as an equation, the first equation 1. Okay, equation 1 also have this side we do the same. So here we divide this one there is what, 7. So here we have 3, 5, 7, then is equal to, here it's 2 there, 7, here it's 2. Okay, here it's 2, 2 there, it's 1, 2 there, it's 7. Then this one into here we are not going to multiply. First thing, we maintain what we have, 2a plus, here is 13d, we close. So over 7 over 7, 7 there, 7 there, it will go. So here what we have, it's 7. Okay, here you have 2a plus 13d. Okay, this is what we have. Then we can divide 7 there, it's 1, 7 into 35, it's 5. Okay, 7 into 7, it's 1. So here we have 51, which is equation 2. Okay, so we have something like this. Then we are going to solve these two simultaneously. So solving these two simultaneously, we are going to use elimination method. Okay, so we have this one, which is 47. Sorry, 47 is equal to 2a plus 11d. Then we take this one, which is 51. Okay, is equal to 2a plus 13d. Okay, so here you find the operation that when you had, you are able to eliminate certain letters. So the first letter that can be eliminated here so easily is what, a here. Okay, so we're going to eliminate a. Eliminating a, so the operation that we're going to use, a minus. Okay, so 47 minus 57. What's the answer once we subtract here? So here we'll get a negative 4. Remember, you can use a calculator. Then this and this will get what, a 0 here. So here it's 11d minus 13d will get what, a negative 2d. Okay, so something like this. Then you can divide by by -2, -2 this side, -2 this side. There will go. Then our D here, this one into this will be 2 is equal to D. So here 2 is equal to D. So having 2 as equal to D, then we can pick each one of this to find the value of what? A, which is the first term. Okay, so we have D here, we have the common difference, then we'll pick this one, which is 47 is equal to 2A plus 11D, and we are saying that this D is equal to what? 2. So where there is D, we replace by what? 2. Okay, where there is D, we replace by 2. So having this one, we'll say 47 is equal to 2A, okay, plus 11, then 2 like this. Okay, so here it will be a 22. Once you multiply 11 times 2, we are going to have a 22. And this one, find the additive inverse of this one. It will also be what? A negative 22. Then you had both sides. So it means that here we're going to have 47 minus 22, which will give us here it's 2A. Whatever that you do here, this is 7, this is 2. So here we're going to have 5 there. So here we're going to have 25 is equal to 2A. So having this one, we'll divide by 2 here, also by 2 this side. Okay, we'll divide by 2 this side. After dividing this and this, will go our A here. A is equal to 12.5. This one into this is 1. There is 2, remainder 1, which will give us 12.5 as our first term. So what we have here, we are saying that we have D is equal to 2, and the first term is equal to what? 12.5. Now the question is to find the seventh term. Here the question is to find the seventh term. So to find the seventh term, we'll say it's this formula here, number of terms. Okay, number of terms. So we'll say Tn is equal to A plus open bracket n minus 1, we close, is equal to D. Okay, so we have this where in this case our n is equal to 7, because we are calculating the seventh term. Okay, so you'll say T7 is equal to our A's first term, which is 12.5 plus EH7 minus 1, we close, then D is equal to 2. Okay, so this is what we have. Then from there we say it's 12.5. Then this and this here, we get a here and here, it's a 6. Okay, 6 times 2, which will give us 12 once you multiply there. So here I've got 12.5, then plus 12. So 12 plus 12.5, we are going to have, which is this and this, we are going to have 24.5 as the seventh term. So here the seventh term is equal to 24.5. Okay, so this is the answer, and just answering the whole of this, you get what? 5 marks. You get 5 marks. This is the beautiful about addition mathematics, because it has got a lot of marks. Okay, so now the second question. The first, second, and third terms of a geometric progression are this one, and this one respectively. Calculate the value of R. Okay, so here what we have the first one here. For us to calculate the value of R, we have the first term, which is y plus 5. Okay, this is a GP. Okay, then y, then again we've got y minus 4. Okay, this is what we have. Then we know that this one represents the first term, this one here second term, this one here third term. Then to find the common ratio, the common ratio formula is R is equal to second term, okay, over first term, or third term, okay, over second term. So this is the formula. I'm going to use this one. So here, since we don't have the value of R, so we are going to use this part here. We just use this part. So having this part, we are saying that where there is this one here, which is the first term replaced by y, second term replaced by y. So here we'll say y, then over y plus 5, okay, then is equal to third term is y minus 4 over y. Okay, so we have something like this. Once we have this, so we can multiply this and this, we'll get a y squared, okay, is equal to, okay, so here now we'll say it's y minus 4 by y plus 5. Okay, so this is what we have. Having something like this, which means we are multiplying this and this and that, then so on and so forth. Or we can write in an expanded form, which is y squared is equal to y here, we'll say it's y multiplied by this one, which is y plus 5. Okay, we close again, there is a minus 4, then you multiply by y plus 5. So this is what we are going to multiply. Okay, y squared is equal to y times this one. I'm going to have y squared plus 5y, which is y times 5. Then here there's a minus, this and this, we're going to have 4y, then this and this is a minus, there is 20. Okay, so you can check, yeah, this is what we have. So having this this one and this one, it will give us, when this one crosses the equal sign, or we are just going to add what we can, then we collect the like terms. So collecting the like terms, this one here, it will be y squared minus y squared is equal to, here we have 5y minus 4y minus 20. Okay, so we have something like this. This and this, it will give us a 0. Then okay, so here 5, so here we have a 0 is equal to this and this. We are going to have y minus 20. So to find the additive inverse of this 20 here, we'll say is plus 20. So even this side, we will say plus 20. Okay, so this plus 20 here, we're adding 20 to 0. Okay, adding 20 to 0. So here we'll say 20 plus 0, even this side. So this is the additive inverse, we say. So this one will reduce to 0, and then here we just remain with y. There 20 plus 0, it will just give us what? 20 is equal to y. So here, if you want, you can utilize this one to say y is equal to 20. This is the value of y, 2 marks. Okay, as you can see, it's very simple, this one, and you get what? A 2 marks. Okay, so this is how we have found the value of y. Now to find the value of the common ratio, to find the common ratio here, you can just pick like this one here. Okay, so we'll take it from this side, since we said a common ratio is 2. Okay, B2, it is B2. So B2, we said R is equal to T2 over T1. Then we have this one here, which is y over y plus 5. So where there is y, we replace by 20. Okay, so say 20 there over 20 plus 5. So this is what we have. Okay, this is what we have. So having this, we'll say it's 20 over 25. Then here you look for a number that can go in both, which is 5. Okay, 5 into 20, it's 4 over 5 there is what? 5. So therefore we are saying that our common ratio, which is R, is equal to 4 over 5. So this is how we can handle this question. Thank you very much. Remember to subscribe and also share this content. Thank you.